Hello, this is Paul from Foresight Tech. In this lecture, I'm going to show you a formula about the mean or the standard deviation for binomial distribution. This is a very important property for this type of distribution. And here's the summary, okay, for the formula. If I give you a random variable and it follow binomial distribution NP. Of course, n is the number of total trials, and the p is the probability of success. And then what is the mean or expected value? The mean mu is equals n times p. Okay, just these two parameter times together. What is the standard deviation? Sigma is the square root of npq. Q is 1 minus p, which is the probability of failure. We already know, right? Okay, so did the formula. So mu sigma, do you remember what the variance? Variance is the square of the standard deviation, right? Square of the square root, which means npq. We cancel the square root. And these three are very important properties for this type of distribution. Later I have example show you how to find this. Okay, use this formula. But first I show a little bit. And this is complicated, really. But we will not go to the detail. See, I put a dot here. Okay, so we don't go to the detail. So first, how to prove this? Okay, remember what's the definition of the mean? The definition of the mean is based on the probability distribution, right? Px. However, we already have a px for binomial distribution. Do you remember the last topic we have? So p. When the success time equals R, I mean the R successes among n. What is the probability? The probability is this, okay? And the first is a combination. We choose R from n. And then P raised to the P is the success probability, right? And the P raised to the R success. Okay, each success has a probability P. And then n minus R value, each value has the probability Q, which is 1 minus P. What's the possible value for the variable for success terms? From 0, 1, or goes to the maximum success is n times. And remember this. And now we use the formula. And the mu is x times px, right? And the value times the probability of the value. See, the value, when the value equals R, this is the probability PR. Okay, the value times the probability, and then what is the index R? R is go from the smallest 0 go to the maximum n. Okay, the middle step I skip here. Okay, a lot of calculation. However, if you have time, please go to Google to check. You will find the properties of a lot of combination. Use that, we can find the final very simple result here. The second, what is the standard deviation? We use the definition is square root of sigma summation, right? X minus the mu, okay, minus the mean square times px. Okay, if we plug everything is like this, okay, and the same I skip. We still use a lot of properties for combinations, and then we will find this final simple one. This is not a difficult, right? It's already very simple. So you look at it, the beginning is complicated. However, the answer is very simple. I give one example to understand what the mean, what's the expected value mean, okay, in this type of distribution, okay. And suppose we have a binomial distribution 100.5. What does this mean? Means you want to do a game, okay, for 100 times. And each time you have a half probability, 50% you win, 50% lose, right? Okay, now what is mu? Mu means you play a lot of times. What is your in average speaking, what's your expected win times among 100? What is? You play 100 times. What's the expected value of the time that you win? Okay, we follow the formula. How to do? The formula is n times p. Okay, what's n? N is here. P probability is here. Okay, I use 100 times 0.5. What do we get? We get 50. Does this make sense? Does this expected win times expected success is 50? Make sense? Yes. Why? You can imagine you play 100 times. Each time you have a half, or probably you can think each time you win half a time. Okay, and then 100 times, of course, you win 50 times. Or whatever, this is expected. You expected to get this. And if you draw distribution, this is the middle. Okay, this is the center data. Now I will give you example how to exactly find the mu and the sigma. So look at the first. Because we have the formula, so the calculation should be super easy. Okay, and we just follow the formula. Can we see the first? Before we're going to find the mu, what do we need? This is binomial, right? Distribution. From here we can find the n, right? So from here we can find the p. P is 0.2. Okay, and then we directly follow the formula. What the formula? So the formula mu equals n times p, right? Okay, so n equals 38, and the p equals 0.2, and the two calculation should get how many? 7.6, right? Okay, 7.6. This is the mean, average. This is the average. Look at the second. Find the standard deviation. How to find standard deviation? We have a formula. Later we copied the formula. First, determine here's n, and here is p, right? Remember in standard formula, I put it here first. No, sorry. It's standard deviation sigma equal this formula. Can you see? MPQ. What is Q? So I'm going to find the Q. Q is the probability of value. Okay, is 1 minus the opposite of success. The success is P. Okay, I use 1 minus 0.2. What do we get? 0.8. 80% chance you will fail. Okay, and then plug everything. This and this and this here. So what do we get? So it's a square root. N is 29. P is 0.2. Q is 0.8. Okay, you use a calculator. Let me see. I already get it. Is use calculator, get a round number 2.15. This is the standard deviation. However, if I ask you one more, so what's the variance? Can you tell me what is the variance? What is the variance? Okay, of course we can use the definition. The variance is the square of the standard deviation. Okay, so standard deviation you already find 2.15, so it's 2.15 square. Or remember, we can directly use MPQ. Why sigma square equals MPQ? Or we can do this: sigma square equals MPQ. Do we have an MPQ? Yeah, we do have. Or is MPQ is 29 times 0.2 times 0.8. Okay, I skip. So you can find the answer. Okay, thank you.